the farthest galaxy ever seen. The James Webb Space Telescope doesn't just see farther than any instrument in history, it sees in wavelengths of light the human eye cannot perceive. And since it launched, it has been quietly dismantling everything we thought we knew about the universe. The universe is 13.8 billion years old. For the first 300 million years of its existence, there were no galaxies, just darkness and hydrogen slowly cooling into chaos. Scientists called this era the Cosmic Dark Ages, and for decades, we had no way of seeing into it. Then Webb found Jade's GS. This galaxy existed just 290 million years after the Big Bang. Webb didn't just detect it, it saw it clearly enough to measure it, and what it found should not have been possible. This galaxy was enormous. Hundreds of millions of stars are already burning, already stretching 1,600 light-years across. And here's the part that stopped astronomers cold. It already contained oxygen. Oxygen doesn't just appear. It has to be forged inside stars, which then have to explode, die, and scatter their remains across space. For oxygen to exist here means multiple entire generations of stars had already been born, lived full lives, and died within the first few 100 million years of the universe's existence. Every model we had said that was impossible. The universe hadn't had nearly enough time, and yet, there it was, the lemon planet that rains diamonds. In March 2025, Webb pointed at something that shouldn't exist. A planet orbiting a dead star. Not just any dead star. A pulsar. The spinning radioactive corpse of a sun that already exploded in a supernova, violent enough to outshine an entire galaxy. This planet completes a full orbit in just 8 hours. Its day side is baked at over 2,000 degrees Celsius. Webb captured its atmosphere. No hydrogen, no water, no methane. Just helium and carbon. Enormous chains of carbon molecules drifting through a poisoned sky. And under the heat and pressure of the pulsar's gravity, those carbon chains condense, crystallize, fall. It rains diamonds on this planet. Not metaphorically, actual solid diamonds falling through a helium sky onto a world that has no business existing. And the pulsar's tidal gravity has stretched the planet itself, squeezed it, warped it into the shape of a lemon-shaped diamond rain planet orbiting a radioactive stellar corpse. Webb took the spectrum. The data is real, and scientists are still trying to explain how any of it is possible. The hint of alien life. 120 light-years away, there is a planet 8 times the mass of Earth sitting in the habitable zone of its star. Webb looked at it in 2023, and the data that came back triggered the most careful, most quietly electric reaction in the history of modern astronomy. K2-18b has an atmosphere. Webb confirmed methane, carbon dioxide, water vapor. Exactly the kind of chemistry that makes a planet interesting. But that wasn't what stopped everyone. Buried in the data was a faint signal. A molecule called dimethyl sulfide. On Earth, there is only one known natural process that produces it. Living organisms, specifically marine phytoplankton, exhaling it as a byproduct of being alive. Scientists were immediately cautious. The signal was faint. Nobody announced anything. Nobody used the word life. But here's what they did say. K2-18b is now one of the highest priority targets in the search for extraterrestrial life. Webb will keep looking at it. Because if that signal gets stronger, if it shows up every single time, the conversation that follows will be unlike any in human history. We may already have the data. We just don't know yet what it means. Neptune's rings back from the dark. In 1989, Voyager 2 flew past Neptune at 60,000 kilometers per hour. In a single fleeting week, it captured Neptune's rings, thin, fragile, almost invisible. And then the spacecraft vanished into deep space. For 33 years, no telescope on Earth was powerful enough to see those rings again. Then Webb took one infrared photograph. The rings came back, not as a blurry suggestion, as crisp, defined arcs of dust and ice glowing in infrared light. Light our eyes cannot see, but Webb sees perfectly. And Neptune itself looked nothing like what you'd expect. In Webb's view, the planet isn't the deep blue marble from textbooks. It appears bright white, almost ghostly, streaked with glowing methane ice clouds high in the atmosphere. Some of the rings captured had only ever been theorized, never confirmed. Webb saw all of them in a single image taken one afternoon in September 2022. 33 years of darkness. One photograph. The first breath of another world. For decades, we could detect planets. We could calculate their size, their mass, their orbit, but the actual atmosphere of another world was invisible to us. In 2022, Webb changed that forever. WASP 39b is a gas giant 700 light-years away. As it crossed in front of its star, Webb captured starlight filtering through the planet's atmosphere, molecule by molecule, and returned the most detailed alien atmosphere reading ever recorded. Water vapor, sulfur dioxide, carbon monoxide, and then carbon dioxide, clear and unambiguous. The single cleanest detection of a gas in an alien atmosphere in history. That moment matters more than it sounds, because the same technique Webb used on a massive gas giant works on smaller planets too, on rocky planets, on Earth-sized planets in habitable zones. Webb just proved it can read the air of other worlds. We are now waiting to find one that smells familiar. The black hole that existed before its galaxy. Everything we understood about galaxies started with one assumption. Stars form first, billions of them clustering under gravity over millions of years, and deep inside, a black hole slowly grows. Stars first, black hole second. That was the rule. 700 million years after the Big Bang, Webb found an object at the edge of the observable universe. At its center sat a black hole weighing 50 million times the mass of our sun. Webb mapped the gas around it, confirmed the mass directly, and then came the number that broke the model. That black hole wasn't a tiny fraction of its host, the way black holes in modern galaxies are. It was 2/3 of the entire mass of everything around it. In our own Milky Way, the central black hole is less than a fraction of a percent of the galaxy's total mass. This black hole didn't grow inside a galaxy. The galaxy was still being born around it. The black hole came first. The stars came second. The rule was backwards, which means the formation of galaxies, the formation of everything, including the solar system that made this planet, and every living thing on it, may have started not with stars, but with a black hole collapsing out of raw darkness. We have been reading the history of the universe backward, and Webb is only 3 years in. If you made it this far, hit subscribe, because at the rate Webb is discovering things, the next rewrite of the textbooks is already on its way.